My co-speaker today is Scott Ostapovicz, who is the co-chair of the XAM SDK, and we'll be trading off different parts of this particular talk today. And we want to keep it fairly interactive, so if you have a question, just raise your hand. The session this morning went over what XAM is from an overview point of view, but it's not necessarily a prerequisite for this class. So if you have a question on XAM itself, just stop us and we'll explain it. Okay? So standard SNIA legal notice. This is also a tutorial at SNW. So we've expanded on that tutorial, and we'll show you some more interactive stuff this week than you would get if you showed up at SNW. So I want to briefly go over why SNIA is doing software and what the rules are for doing software. The XAM SDK work is being done in what's called a technical work group within SNIA, and there's other software technical work groups that are going to be available in the future. And then we're going to dig down into the actual XAM SDK twig, what we're working on there, what the structure of the code is that we're developing, and look at other possible twigs that could be developed. But we're going to really spend most of today talking about the actual XAM SDK, what code goes in there, what the structure of that is, what the API looks like, how you can develop to it in various ways. There's operating system vendors, there's storage vendors, and then there's application vendors. And all these things kind of come together in this SDK. I apologize because I don't have a remote capability of moving the slides. Yeah, if you could hit the space bar every so often, that would be great. So, the problem that we're trying to solve with software work in SNIA in general is that of adoption and maturation of our specifications. You probably are very familiar with a lot of the SNIA specifications we already have out there. SNIA, the HBA API was developed within SNIA, the iSCSI management API, the multipath management API. There's talks on all those this week if you're interested. But doing specifications is great up to a point. When you develop new APIs and protocols for storage and data and information domains. But if I'm a vendor wanting to implement one of these specifications, and I get this, whether it's a 1.0 or 2.0 or even a pre-1.0 specification, I kind of have to interpret that specification and make some implementation choices when I read that spec and when I create my own code. And in order to mature the specification quickly, we need to get multiple vendors to do that. And so SNIA, especially SNIA, has something called a maturity model, where they actually attempt to describe what they think the maturity of a specification is based on how many vendors have implemented it and tested it against each other, right? We do have plug testing, plug fests. There's a couple of plug fests going on upstairs. iSCSI and CIFS plug fests are standards that SNIA does not create themselves, but we facilitate the plug festing of other people's standards. We do have plug fests in the area of SNIA, and we specifically drive specific content into those plug fests so we can shake out the newer parts of the specification and get them mature as possible. But plug testing is kind of late in the game, if you will, because it's already after vendors have made their particular implementation choices. They've already decided how to interpret the spec. And when you show up at the plug fest, that's when you find out that two vendors have interpreted the same specification differently, right? And then you realize, oh, well, the specification isn't quite tight enough in that area. And so we need to fix the specification, right? And that whole process of making implementation choices, testing against each other, and then fixing the spec can take a matter of months or even a year or so before you get, you know, a new rev of the spec out for everybody to use that's a little bit tighter and better.